Yo, 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 yo. We're going to use Pythagorean theorem in this video to find the distance between 2 points. So let's just get into it right away. So what we're going to look at is we are going to look at a coordinate plane, and on that coordinate plane we are going to find the distance between 2 points by maybe creating a right triangle, or not maybe, by creating a right triangle. So for example, here I have a right triangle. If I wanted to find the distance from, let me fix this a little bit, here we go, from this point to this point right here. Well, what I need to do, because when we're looking at a coordinate plane, I can't count this distance because this is diagonal. Like this is not equal to 1. Because we're not going straight up and down or left and right. So when it's diagonal like this, we can't just count the point. So it makes it difficult to figure out the distance. Now, when it's horizontal, we can easily count. Like this one, right? This leg right here is 2, and then this height right here, this leg is 4. Because we can just count 1, 2, 3, 4. But diagonally, we can't do it. We can find the slope of it, but that's not necessarily distance. So what we do is if we're ever looking for the distance between 2 points, we create a right triangle. This one was already created for us. And then we use that right triangle to use Pythagorean theorem and to find the hypotenuse. So if I have a right triangle with a leg of 2 and a leg of 4, I can now find the distance of this line by doing 2 squared plus 4 squared equals c squared. So that's 4 plus 16, which is 20. So now I can find the square root of 20, which is 4.5. So this distance is 4.5. And that's it. Okay, so it's using the grid to count the length of your legs, and then we will find the hypotenuse by using Pythagorean theorem. So another example here, I have a right triangle. I want to find the distance of the hypotenuse, so the length of the hypotenuse, that's from here to here. That's this line. So I need to figure out the length of the legs, and then I can use Pythagorean theorem. Well, this leg is 1, 2, 3, 4, 5. 1, 2, 3, 4. So I know that's 4 squared plus 5 squared equals whatever my hypotenuse is, which is c squared. 16 plus 25 is 41. So when I take the square root of 41, I get 6.4 to the nearest tenth. So the hypotenuse for this one is 6.4. Now, one thing you're going to have to do is maybe look at some word problems or some pictures, and we're given points on a coordinate plane. So now we can't really count. So like for here, Francesca wants to find the distance between her house on one side of a lake and the beach on the other side of the lake. She marks off a third point, forming a right triangle as shown. So here's my right triangle. So I need to figure out what's the length of this leg, what's the length of this leg, so I can figure out the distance from our house to the beach. Well, what we know about going left and right on a coordinate plane is these are the x values. So if we notice the y is still at 20, but the x goes from 10 to 280. So to figure out this distance, I can subtract 280 minus 10, and I get 270. So this leg right here is 270. Well, now if we're going this leg, we're changing the y values. We're going from 20 to 164. So I can subtract 20 from 164, and I get 144. So this leg is 144. So sometimes you might have to subtract the points, or subtract the x values or the y values to find the legs. And again, but now that I have that, I can use Pythagorean theorem. 144 squared plus 270 squared equals, and the distance we're just going to call it x squared. Now these are some large numbers here, so this is where it'll be really nice to have a calculator. Imagine not having a calculator for this. Well, you could do it. It would just be a lot of work. So when I add these up, I got 93,636 equals x squared, and now I can just find the square root of that. And it worked out really nicely to get 306. So the distance is 306. All right. Finally, you might have to graph points on a coordinate plane and then find the distance between those 2 points. So I want you guys to try this on your own. I will help you graph the points though. To find the distance between the points 3, 7. So remember, this is your x, this is your y. So 3 is 1, 2, 3. 7 is up. 1, 2, 3, 4, 5, 6, 7. So there's the point 3, 7. And then 15, 12. So 15, 12 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Uh-oh. 14, 15. And then 12 is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm looking for the distance between these 2 points right here. Try it on your own. Create a right triangle. See how you do. So pause it, try it, see what happens. Okay, so here's my right triangle. And you could have also gone this way as well. It doesn't matter because they're going to give you the same length for your legs. Okay, so these are your 2 possible right triangles. And here's the hypotenuse for both. Now the distance from the legs, as we know, is the distance from the y values, from 7 to 12. And I can count that up here, which is 5. Right? Because from 7 to 12, it's going to go up 5. Now to go from 3 to 15, it's going to go over 12. And I could have counted 12, or I can just look at if I'm going from 3 to 15, it's going over 12, or you can count it. So really it's just 5 squared plus 12 squared equals c squared. 25 plus 144, 169, which is 13. So that's side length. The distance between those 2 points is just 13. Okay guys, that's all I got for you guys today. So we're going to keep using Pythagorean theorem, and that's it. So if you have any questions, let me know. Thank you for watching. Greedius out.